let me go show you on the computer in 6.2. You've got two things on NPX. And I'll write these down also. NPX, there's two things in 6.2. NPX, and the computer and the question will ask for the probability. Okay, it's going to ask for the probability. And you need to know your inequalities. You need to make sure you know that you know what at most means. At most means that your highest number is that number. So at most 4 would be 4 or less. So at most, at least, you need to make sure you understand that at least means the lowest number is like at least 2. Your lowest number is 2, and that less than less than 2 means 0 and 1. More than 2 means 3, 4, 5, and 6. Remember, this is inclusive. This is inclusive, meaning that you can use the number that you're writing down. So at most 2, I can use 2. At least 3, I can use 3. Less than is what? What's the opposite of inclusive?
Exclusive.
Exclusive. Exclusive. Okay, so when you're using PDX, MPX, they may say equals to, and of course that's precise. That means the point. That means on point. And then you got these 4 right here. So NPX, you're going to be dealing with these. With NPQ, which is the second part of 6.2, they're not going to ask for the probability. They're going to ask for the mean and the standard deviation. So just like all questions in probability and statistics, what do you have to do to the question before you start? You got to read it. Okay, you got to read it. It's either going to ask for the probability, you use NPX, or it's going to ask for the mean and the standard deviation, use NPQ. And Q is the complement of P. The mean is equal to N times P. The variance is equal to NPQ. And the standard deviation is equal to the square root of the variance, or variance raised to the 0.5 power. Now, on the calculator, now you don't need this on the calculator because all you have to do is punch in numbers and multiply. That's not hard. But over here, you got 2 things that you need to make a note of. Second, bars. These 2 right here. PDF, normal PDF, I'm sorry, binomial PDF, sorry. Binomial PDF stands for precise. P, meaning the point. So when it says, what is the probability of 5? Then you're going to use PDF because it's equal to that point, 5. These guys up here, you're going to be not using PDF, you're going to be using CDF for these guys. Binomial CDF. CDF means cumulative, meaning that you're adding them up as you go. I'll show you an example here in just a second. So for 6.2, you got two sides. The question is going to ask for the probability, or it's going to ask for the mean and the standard deviation. If it asks for the probability, you're going to use NPX, and you're going to use either binomial CDF or binomial PDF. If you're dealing with the mean and the standard deviation, you're just going to be dealing with multiplying numbers. Okay? Okay. So here's an example. And I always tell students to use a number line. Use a number line when you're dealing with these, and it'll make a whole lot more sense. But of course, how many of you actually printed these out? You're not going to listen to me anyway. So for those that do listen to me, you might want to use a number line. So here's an example. Research tells us out of 50 households, 0.37 watch a certain TV show. What is the probability at most 10 households watch the show? Okay, I'm not going into all kind of details, but this is how it's going to be written. Here is the trials, that's N. Here is the probability, that's V. And here is the X. But the problem is, what is it asking? Well, at most means what? That means the largest number is what? Is 10. So I'm going to draw a number line. Okay, so you got a number line, households, from 0 to 50. And they're asking at most 10. So somebody tell me what at most 10 means. That means
10 is the most that you can have.
So that means that we've got to do the probability of 1 to 0 through what?
10.
So we can do it two ways. We can add each one of these up, NP0 plus NP1 in your calculator, plus NP2 plus NP3. We can do it that way, or we can do a cumulative up to 10. So we're going to do a cumulative because I don't think anybody, heck, I can't even get y'all to print these out. You think I'm going to get y'all to add each one of these up? So we're going to do normal. This is a CDF. We need cumulative from 0 to 10. Are we including 10? Yes. At most means you include 10. So it would be X is 10. So I'm going to give you an example of one that's not inclusive in just a second. So we do normal. Binomial CDF 50.37 and 10. And the CDF will tell the calculator to add all these probabilities up to 10. So we take our handy-dandy calculator and we do normal CDF. And we do 50.37 and 10. If you got an older calculator, when you type in binomial CDF, it'll have a parenthesis here, and you type in 50, 0.37, 10, close parentheses, and hit enter. So you got a 1% chance, 0.0076. 0.0076, a 1% chance that the 10 people are going to be watching this TV show. All right, now here's the alternative. And I'm going to write this in pink. Okay. What is the probability that more than, and well, let's say less than 5 watch the TV show? Well, graphic. What's less than 5? That means I want somebody to say it. What's less than 5?
Means you use any number below 5.
4.
Do I include 5?
No.
No. So in this case, you would do cumulative. So you would do in pink, you would be binomial CDF 50.37, and not 5, but what?
4.
4. Okay, so that's how you do that. Now, the other type of 6.2 question is going to be like this. A company has 300 employees with a 35, or let's go 0.25 or 25% safety violation, whatever, safety violations. In other words, they have problems with safety. What is the mean and standard deviation? Well, here, these two problems ask for two separate things. This problem asked for what? This problem asked for probability. Probability. This problem asked for mean and what? Standard deviation. So I don't want you to come to me saying, I don't know when to use what. Well, you need to read the question. All right, so this one the mean, I lost my black pen. How did I lose my, there it is. My mean is equal to N times P, which is equal to what? 300 times 0.25. Well, 30% is going to be 60. Well, 20%, yeah, 20% is going to be 60, and then half of 30 is 15, so that would be 75. Somebody check my math. What's 25% of 300? Somebody take 0.25 and multiply it by 300, please.
70.
Is 75?
Yeah, 75.
So the mean is 75. Standard deviation, or variance, is equal to NPQ, which is equal to 75. That's N times P. Please tell me you're not going to multiply that twice. 75 times the Q, let me write up here, Q is equal to 0.75 because P is equal to 0.25. So Q is equal to 0.75. And somebody multiply 75 by 0.75 for me. What do you get? $75 times 0.75. Thanks a lot. 56.25. And then the standard deviation is equal to the square root of 56.25, or 56.25 raised to the 0.5 power, which it comes out to be what? 7.5. And that's how you do the two types of problems in 6.2. And that's where we left off. We left off with 6.2 last time we met, Wednesday. So just as a go over, in 6.2, you have two types of problems: probability, NPX, and mean and standard deviation, NPQ. This is what an NPX will read like. Okay, there's two questions here. One, what is the probability at most 10? What is the probability that less than 5? And there's how you do it. What did we get for that probability of less than? Somebody tell me what that probability came out to be. 50, 30.37, and 4. That's all right. I'll do it.
I'm doing it.
That's all right. I don't want one person doing the whole work for everybody because they're too lazy and they're working on other assignments for other classes. Normal, CDF, and that's going to be 50. No, that's not normal. Hold on a second. Second quit. Second bars. Binomial. Binomial CDF. And that's going to be 50.37. That's why I asked students to do this for me, so I don't have to do it with the mouse. But I can't get students to help me, so that's going to be 5029. 1, 2, 3, 4, 5, 2, 9. Okay, so that's the answer there. Basically, zero probability. 4 people are watching the show. The show must really suck. And then this is a problem that you would get, and it will say, what is the mean and standard deviation? It won't say, what is the probability? What is the mean and standard deviation? So in 6.1, you're asked to find the probability of a probability distribution. Okay, and then you're asked, that's number one, and then you're asked to find the mean and the standard deviation of a probability distribution. In 6.2, you're asked to find the probability of a binomial probability distribution. And you're asked to find the mean and the standard deviation of a binomial probability distribution. Okay, of course, this one, but the probability is NPX. And the mean and the standard deviation is NP. And NPQ, square root of NPQ. Up here, we had those formulas. We had the summation. The mean is equal to the summation of x times p of x. And the standard deviation is equal to the square root of x squared times p of x minus summation minus mu squared. Okay? And the probabilities, we just either added them up or picked them out of the chart or the table. So that's 6.1 and 6.2. Now, 7.1 and 7.2, you're going to be dealing with curves. The first curve you're going to be dealing with, and you're only talking about 1 or 2 questions on the test, is uniform distribution. Uniform distribution is usually when you're dealing with time. Because what is the only thing that man cannot screw up? You're supposed to say what I just said, time. Okay? Man cannot touch time. That's why it works so perfect. Because we haven't screwed it up. Okay? It's uniform. That means that the curve for uniform distribution is what? A rectangle. Because it does not vary. It does not have any variation. 10 minutes is 10 minutes. 20 minutes is 20 minutes. So area is equal to length times width, or base times height, whichever one you want to call it. Since this is on its side, we're going to say base times height. This is your height. And this is your base. The base is usually given in time. Usually minutes. And then the height is just height. The area under the curve, the area under any curve, I'm going to put this in red because somebody's going to ask, where'd that 1 come from? The area for any curve in probability and statistics. And this does constitute as a curve, even though it's a box. In probability is equal to 1.0000. Now, I put the 4 decimal. I put 4 because 4 decimal points usually means area. So I'm going to put 1.0000. And the only reason I'm putting 4 zeros is 4 zeros, 4 decimal places usually means area. When you see 4 decimal places in 7.1 or 7.2, that usually means area. Now, I've said that 3 times. Okay. All right. So here's an example of what you'll see. This is 2 examples of 2 test questions. I mean, this is examples of 2 test questions that I would give you. A class meets for 50 minutes. What is the probability that the class meets for 40 minutes? Okay, so you draw a picture. Zero to 50, 1.0000. So the height would be 1/50th. Now, if you don't, if you need help to figure that out, with area is equal to length times width, or base times height, and you've got the base and you've got the area and you can't find the height, then we need to go back to algebra class. Okay? So they want to know, what is the probability that you meet for 40 minutes? So they're wanting to know, what is this probability right here? Okay, so that's going to be area for 40 minutes is equal to base 40 times the height 1/50, which is equal to 40/50, which is equal to 4/5, which is equal to 8/10. So there's an 80% chance that he will cut off, he or she, teacher, will cut off at 40 minutes. That's how you do uniform distribution. I'm not going to spend a lot of time on it because you're only talking about 2 questions on the test, and they're the same. They're exactly the same, just different numbers. Now I want to get to 7.1, 7.2. Now, there's 2 types of questions, 7.1, 7.2. 7.1 and 7.2, there is the uniform distribution, and then there is normal distribution. Mean is equal to 0, and the standard deviation is equal to 1. So one type of problem is basically based on z-scores. Z is equal to x minus x bar over standard deviation, or if you like the population, x minus mu over sigma, whichever one you want to use. Okay, so this is important. I'm going to highlight this in green because this is very important. Now, the good news is if you've got a new calculator, the newer calculator will do both of these without any problem. The newer calculator, all you have to type in is the mean and the standard deviation and the rest of the information, and it will convert everything. If you don't have a new calculator, you've got to turn everything into a z-score. And I will show you from an old calculator perspective, because anybody can type in the new calculator, but I got to make sure that everybody, you know, from an old calculator up, knows how to do the problem. The second type problem in 7.1 and 7.2 is mu is equal to a number other than 0, like 100, and the standard deviation is more than 1. So I'll just say 10. Again, we're probably going to have to, if you've got an older calculator, you'll have to depend on z-scores. And z is equal to x minus mu over standard deviation. And you might have to do this formula, x is equal to Oz plus mu, to get a test score back. And I'll explain that in just a second. So that's your two type problems right there. And the difference is what you're given. In this problem, you're given 0 and 1. In these problems, you're given 110. Okay? Now, both of these, you're going to be using the normal curve. And both of them, you're going to be using the empirical rule. So I'm going to put that in red. Both, you will be using the normal curve. Area is equal to 1.0000. And you'll also be using the empirical rule to kind of guide you on what the answer is going to be. So let's take a minute and go to the homework. Let me leave that up for a couple more seconds. I don't want to hear no whining when you don't understand how to do these questions. Just going to say that right now. Mr. Smith, or you keep getting kicked out of class, it's probably because of your wireless. You see, back in. Usually that's because the wireless is not really helping out. I'll try to call him back in. Hold on. Smith. If you're using, and I hate to say this, if your internet is crappy wherever you are, that usually is the reason you get kicked out. All right, so here's a question. Let's go to the handy dandy homework. And most of your questions are going to be in 7.2. That's where most of your math questions are going to be. And let me pick one out that I would use as I'd like to do just one, but I doubt they have just one. Yeah, they got 4 or 5. I don't want to do 4 or 5. I want to do one. All right, I'll just make up one. All right, so here we go. I'm going to make up one. I'm going to take my handy dandy curve that nobody printed out. And I'm going to put the question up here. The question will read, with a mean of 0 and a standard deviation of 1, find the probability of being greater than 1.6. Okay? So the first thing you do is you label your curve. 1, 2, 3, -1, -2, -3. And plot 1.6. 1.5 would be right there. So 1.6 would be right about there. And more than 1.6 would be right there. So the empirical rule says 0.15, 2.35, and half of that'd be 6.75, but it's not really 6.75 because half would be 6.75. So I'm just going to say this is probably 6. So our answer should be around 8.5. So the area in here should be around 0.0850 by a guesstimate by the empirical rule. So now we're going to actually calculate it. Somebody tell me what this arrowhead is called right here. What's that arrowhead called?
Outlier.
Negative what? Negative infinity. What's this outlier called? I'm sorry, what's this arrowhead called? Positive infinity. Well, we can't type in positive infinity and negative infinity. So we're from now on, in this 7.1 and 7.2, we're going to call negative infinity negative 9999. And we're going to call positive infinity 9999. So somebody tell me, which way do we read?
Left to right.
So what's our left parameter? 1.6. What's our right parameter?
Positive infinity or 9999.
9999, exactly. Now all you got to do is type that in the calculator. And you go to normal CDF. Normal CDF. Second, bars, normal CDF. And your lower is 1.6. And your higher is 9999. And we're supposed to be around 8%, 8.5%, maybe a little bit off, but okay, we're a little bit off because it's smaller toward the tails. 0.0548. So our actual answer is 0.0548. So the probability of having a score greater than 1.6, probability of having a score greater than 1.6 is equal to 0.0548 or 5.48%. And that's how you do a 0-1 graph. Okay, let me show you how to do a non-0-1 graph. We're going to take our handy dandy curve. Oh, and every single homework problem you're going to do in 7.1 and 7.2 is going to use this curve. So we got a mean equal to 100 and a standard deviation equal to 10. 100, 110, 120, 130, 90, 80, and 60, or 70, sorry. And they want to know, what is the probability of X being between 95 and 115? Bless you. Where are you at, Mr. Long? Are you at one of the campuses?
I'm in the library.
Oh, okay.
I came in a little bit later, so I didn't want to interrupt class.
That's
And
fine. I appreciate
Okay,
that.
sure.
That's very courteous. Thank you. All right, so now we got a plot. 95. 95 would be right in here. And 115 would be right in here. So this is the area that they're wanting. I'm going to use a different color that I've been using with the curve because I don't want you to get it confused with the colors that I use for normal. And so I'm using blue. This is the area they're wanting. So the empirical rule, and I'm going to use a form of blue for the empirical rule. The empirical rule says 17 plus 34 plus what's half of 6.75? 6.75, 0.75, 17, 3, 4, 5. Y'all check my math. I get 57.75. So empirical rule says 0.5775 by the empirical rule. So our answer should be around 55 to 58%, somewhere in there. So now we take our handy dandy calculator. We got to change these into z-scores because we have an old A calculator. And I'm teaching that from the beginning. If you have a new calculator, you type in the mean and the standard deviation where it says mean and standard deviation, and it will do everything for you. So I'm not going to do those because I got to treat everybody like they have an old calculator. So 95 minus 100 divided by 10, and 115 minus 100 divided by 10. And it looks like to me it's going to be negative 0.5. Let's see. 95, that's negative 5. Yeah. Negative 0.5 is your z-score on the left. And then 115, that's 15, that's 1.5 on the right. So we're going to go to our handy dandy calculator and we're going to do negative 0.5 to 1.5. Second, vars, normal CDF, negative 0.5, use the negative beside the enter, and 1.5. And we think it's supposed to be anywhere from 55 to 60%. A little bit off, but that's normal because we're doing empirical rule versus the actual calculation. The actual calculation is 0.6247. 0.6247. So the probability of our score being between 95, let's say these are IQ scores. What's the probability with this given information that your IQ score is going to be between 95 and 115? Well, that's going to be, you got a 62% chance of falling into that category. Now, why do you have to use this? Because sometimes they ask for between, sometimes they ask for less than, sometimes they ask for greater than. Okay, and I've yet to see a person use no pictures and understand what you're doing in this class, or 7.1 and 7.2. Although I know some of you guys are going to try it, but it's not going to work. One more thing I need to show you about 7.1 and 7.2. Sometimes you're going to be given an area and they want a z-score. Okay, so let's take a handy dandy, and they say mean is equal to 0 and standard deviation is equal to 1. Find the area, find the z-score for 0.7619. So the area is 0.76. Now this is 50%. This is 84%. So 76 will be somewhere in here. So all of this over here, 0.7619. So we don't have a z-score. So what do? Well, the calculator will do it for you. Second, vars, inverse norm. This is when you need to find a z-score and you're given an area. I'm going to highlight inverse norm because some of y'all that are not listening, y'all are going to come to me and ask me, how do you find that? And I'm going to look at you like I have no earthly idea. Inverse norm. You were working on your science or your speech during my class, so inverse norm. So go to second, vars, inverse norm, and type in 0.7619. Now, when we do homework problems Monday, because you will be sending me 7.1, well, you'll be sending me homework problems, even though it's against the creed of the class. There will be some of y'all that are going to be like, bump the class, I'm going to send questions. All right, there's going to be some questions Monday. I will show you how to use the new calculator versus the old calculator. Right now, I'm doing everybody by the old calculator. Left tail because it's on the left side, and paste and enter. 0.71 is the z-score. So my z-score is equal to 0.71. Why did you just round to 2 decimal places, Hubert? Because in 7.1 and 7.2, 4 decimal places equals area. 2 decimal places is usually a z-score. Now, the book doesn't do that, okay? That's something that I tell my students. When I write down a z-score, I'm only going to take it to 2 decimal places, okay? Okay. Now, that's what I wanted to get in today because I want y'all to work on 6.1, 6.2, 7.1, and 7.2 homework. And I don't have to worry about questions being sent because I know there's going to be questions being sent. Okay? So let me take the roll. And if you don't mind waiting for a second, let me turn off the recording and do jiggers.